Hi students, in today's video session, we are going to discuss a new technique for the synthesis of nanostructures called sputtering. Now what is sputtering? It is a physical vapor deposition process whereby atoms in a solid target material are ejected due to the bombardment of the material by energetic ions. So in the process of sputtering, we firstly take a target material and there is something called the substrate. This method is commonly used for thin film deposition. So the substrate is the material on which the thin film is going to get deposited. And target material is the material whose atoms are going to constitute the thin film. Now, an energetic positive ion is made to be incident or is allowed to hit the target material. Now, the energetic positive ions chosen are usually argon ions because argon is a non-reactive gas. So, this ion will not react with the target material. So, an energetic positive ion is allowed to collide or allowed to bombard the target material. Now here a momentum exchange takes place between this energetic ion and the atoms of the target. That is, momentum is transferred from the positive ion to the atoms of the target, and the atoms in the target undergo mutual collisions, and as a result one or more atoms get ejected out from the target material. These are called sputtered atoms, and this ejection of the target atoms when the target material is bombarded with the energetic positive ions is called sputtering. Now the sputtered atoms will travel towards what I call this substrate, and they condense and deposit on the surface of the substrate to form the thin film. So this is what takes place in the process of sputtering. Now for sputtering to take place, we require energetic positive ions. I told you we usually use non-reactive gases like argon to form these positive ions. Now how can you create the positive ions? The most simplest and the most common method for creating the positive ion is by means of a glow discharge. Now what is a glow discharge? A glow discharge unit comprises of a glass tube filled with whatever gas we are taking. That is, if it's argon, the discharge tube or the glass tube will be filled with argon, and there will be two electrodes inside this discharge tube. Now, when a potential difference is applied between the two electrodes, what will happen is ionization of the gas will take place and a glow will be produced inside the discharge tube. This is called glow discharge. As a result, the gas gets ionized here into positive ions and electrons. That is, a plasma is being formed. This glow constitutes our plasma. In this manner, we are able to attain the energetic positive ions required for sputtering. Now, how does sputtering take place, or how does glow discharge sputtering take place? The process of sputtering is named as glow discharge sputtering when the positive ions are acquired through the process of glow discharge. So, in glow discharge sputtering, I'll show you the figure here. The glow discharge of non-reactive argon ions is created by applying a potential difference inside the chamber. Now the energetic argon ions, positive ions, will hit the target and the target atoms are ejected. and they get deposited on the substrate to form the film. So this is how, using the technique of sputtering, we are creating thin films. Now, to get a proper film composition, the target composition has to be properly chosen. Usually, in the normal physical sputtering method that we follow, the target material has the same composition as that of the deposited film. However, in reactive sputtering technique, which is used to deposit oxide, nitride, carbide thin films, in this case, the sputtering atmosphere is composed of argon and either oxygen or nitrogen or some hydrocarbons, depending on what final product we require, whether we require an oxide film, a nitride film, or carbide film to be formed on the surface of the substrate. Here, what happens is, once the target atoms get ejected, a reaction takes place inside the sputtering plasma as well as on the substrate, and the required thin film is formed on the deposit. That is, the required thin film is formed after a series of reactions take place in the sputtering plasma as well as on the surface of the substrate. Now, for the reaction to take place, the substrate is put under an elevated temperature. Now, in addition to thin films, nanostructured materials, various other nanostructured materials can also be synthesized by sputtering. Now, I have not introduced to you what is a thin film. A thin film is uh, a layer or a coating or a film which has thickness less than 1 micrometer or less than, say, 1000 nanometer. So, such a layer forms a thin film, having thickness less than 1 micrometer or less than 1000 nanometers. So, in addition to thin films, sputtering is usually or commonly used to produce thin films. Other nanostructured materials can also be synthesized by sputtering, as the material composition, the thickness of the nanostructure, homogeneity, deposition time, substrate temperature, etc. can be controlled by this method. Now we are going to discuss about the process of glow discharge. I've told you, glow discharge is a technique by which we generate the positive ions which are needed for sputtering. So, how do you generate the glow discharge? I've already told you, you take a glass tube with two electrodes inside it, and the gas whose ionization has to be acquired is filled at low pressures inside the discharge tube. Once the potential is applied, the gas ionizes and the glow discharge appears. So, a glow discharge is obtained when a high potential difference is applied between two flat electrodes in a low pressure gas. The gas is maintained at low pressure. Here we are going to discuss the IV characteristics of the glow discharge. So, current is plotted along the x-axis and voltage along the y-axis. Initially, as the voltage is increased, there is no appreciable increase in current. See, the current is much less than 10 raised to minus 9 ampere. So, there is not much appreciable increase in current initially. But as a characteristic minimum voltage called breakdown voltage is reached, when this breakdown voltage is reached, the current increases tremendously, and this takes place at constant voltage VB, that is the breakdown voltage. The current increases to a large value, and this region is called, of the discharge, is called Townsend discharge. After that, the current increases, but the potential decreases. That is, this is a negative resistance region, and it is called the transition region. After that, again, the current increases. As the current is increased further, a second constant voltage region called normal glow is reached. If the current is again increased beyond a certain level, the voltage rises with increasing current, and this region is called the abnormal glow region. So the glow discharge starts at the normal glow and it's completed here in the abnormal glow region. Now it is in the abnormal glow region that the sputtering work is performed. Now if the current is increased further, the voltage drops abruptly and the discharge becomes an arc. We have discussed what is arc or arc discharge in the previous class. So, once again, the IV characteristics of a glow discharge, that is, initially what we do is you take a discharge tube with two electrodes and a high potential difference is applied between the electrodes, and the discharge tube contains a low pressure gas. Now, when we increase the potential difference, initially there is no appreciable increase in current. But once the breakdown voltage is reached, the current increases with no change in potential, or this is a constant potential region with a large increase in current, and it's called the Townsend discharge. After that, as the current is further increased, additional charge carriers are created and the discharge exhibits negative resistance, or the potential decreases, and this is a negative resistance region called the transition region. As the current is increased further, again we reach a constant voltage region called the normal glow. If the current is increased beyond this, then the voltage also rises with increase in current, and this region is called the abnormal glow region. It is in this region that the sputtering activity is performed. After that, when the current is increased, the voltage drops abruptly and we get the arc discharge. So this glow discharge begins in the normal glow region and ends in the abnormal glow region. So this is how the IV characteristics is for a glow discharge. So in today's session, we have discussed what is sputtering, how does the process of sputtering take place, how the momentum exchange between the energetic positive ion to the atoms in the target material takes place, and the target atoms get sputtered and they get deposited on the surface of the substrate where the thin film is formed. Then we told that this method is also used for the synthesis of other nanostructured materials. Then we discussed about the glow discharge, which is a technique used for generating the energetic positive ions, and we discussed the IV characteristics of a glow discharge. I hope the session is clear to all of you. If you have any doubts, please do contact. Thank you.